and let's continue. So we are going to do question 9, okay? Question 9. So question 9, so you see that for this question, we cannot, okay? So we cannot use separating variables method, and also we cannot use the way in section 4.2, it means that we cannot write as derivative of product directly. So here we have to find the integrating factor. So firstly, we should simplify the equation to be dy by dx minus 1 over x plus 2 times y equals 1, okay? And then here, okay? And then we can get p of x is negative 1 over x plus 2, okay? Plus 2. And after that, okay, after that, we can find the integrating factor. So the integrating, okay, factor is e to the power of negative 1 over x plus 2 e to the power of the indefinite integral of negative e to the power of 1 over negative 1 over x plus 2, okay? So it can be written as e to the power of negative ln absolute value of x plus 2, and it will be e to the power of ln 1 over absolute value of x plus 2, and which is 1 over x plus the absolute value of x plus 2. So as we know just now, okay, no matter what we choose, the positive one or negative one, so here we can choose, okay, choose 1 over x plus 2, the positive one, okay, as the integrating factor. So we can have 1 over x plus 2 times to this one, okay, times this one, okay, so it will be minus 1 over x plus 2 bracket square, and then y equals 1 over x plus 2, okay, 1 over x plus 2. And after that, okay, so the left hand side must be the derivative of a product, so it should be 1 over x plus 2 times y, okay, by dx. And you can also check whether it's true or not. So dy, keep 1 over x, okay, and then d1 over x plus 2, it must be negative 1 over x plus 2 to the power of 2, okay, and times y, correct, okay, so it can be written as and then do integration. And finally, okay, so finally, the left hand side, okay, it will be y over x plus 2. Right hand side is the absolute value of the log, it should be ln absolute value of x plus 2, okay, and then plus constant c, okay, plus constant c. And finally, okay, finally the answer will be y equals x plus 2 times ln absolute value of x plus 2, and then plus c times x plus 2, okay, but here, okay, here it is better to add, okay, to add the condition x greater than negative 2, okay, because here if you choose if you choose this one, it means that you know, it means that you know x plus 2 is greater than 0, because you choose this one as the integrating factor. It means that x plus 2 greater than 0, so finally actually we can also write the answer as, so ln x plus 2, remove the absolute value sign. So it is because because you choose, because we choose 1 over x as the integrating factor, but actually it should be 1 over absolute value of x plus 2, but we choose the positive one. It means that x plus 2 is greater than 0, so it means x greater than negative 2, so this is question 9, and let's look at question 13, 13. Find the general solution of the differential equation giving y in terms of x, So firstly, we cannot use the way in section 4.2 to do it, So we have to find an integrating factor, and before we find the integrating factor, we should simplify the differential equation. So we divide, so firstly, so we can write it as x squared plus 1, over x times dy by dx plus 2y equals to x squared plus 1 to the power of 2, to the power of 2, and then we will divide x squared plus 1 over x on both sides, so we can get dy by dx plus x over x squared plus 1, and here I write 2 here times y, and equals, and here actually it can be simplified as 2, it can be 2x times x squared plus 1, because we multiply x and then divide x squared plus 1, so the right hand side will become this, and then so we know px is 2x over x squared plus 1, so now we find the integrating factor, so the integrating is e to the power of the integral of 2x over x squared plus 1. And let's try to integrate. So use integration by substitution, So here it can be written as x squared plus 1, because dx squared plus 1 is also 2x, So d this one, So it is 2x also, So finally you see this will be, this will be e to the power of ln, 1 ln absolute value of x squared plus 1, But you know that x squared plus 1 is positive, So it will be, we can remove the absolute value sign, which is ln x squared plus 1 only, and finally we simplify it to be x squared plus 1, So please remember that e to the power of ln f of x is fx, Alright, so now we find the integrating factor, so we can get that, we can get, pay attention, multiply the integrating factor to the standard format, so we can get x squared plus 1 times dy by dx plus, it becomes 2x, 2x times y equals 2x times x squared plus 1 to the power of 2, to the power of 2. So after that, okay, so after that, we can write the left-hand side to be the derivative of a product. So it will be, okay, so it will be d x squared plus 1 times y, and then by dx, okay, equals 2x times x squared plus 1 to the power of 2, okay? So you can also check whether it is true or not, the left-hand side, okay? So it is true here. And it can be written as all right, and then do integration. And then the left-hand side will be x squared plus 1 times y equals, and how about the right-hand side? So you know that, okay, the right-hand side, actually, we can move 2x inside dx, okay, so which will be x squared plus 1 to the power of 2 dx squared. But if we add a constant 1, it is also the same, okay? So here it is d this one, okay? It is 2x, okay? So now you see, regard this is u. This is u, okay? And then we integrate u to the power of 2 only, okay? So it will be, okay, this one will be 1 over 2, okay? Sorry, not 1 over 2, 1 over 3. It will be 1 over 3 because it is just here. This is just u to the, integrate u to the power of 2 du, okay? So it will be 1 over 3 u, okay? So u is x squared plus 1 to the power of 3, and then plus constant c, okay? Plus constant c. So finally, y can be written as 1 over 3 x squared plus 1 to the power of 2, and then plus c times x squared plus 1 to the power of negative 1, okay, negative 1. So this is question 13a, okay, 13a. And B, find a particular solution. Find a particular solution which satisfies the condition that y equals 1 and x equals 1, okay? So when x equals 1, y equals 1, okay? B, so we can get that, okay? So we can get that 1 equals 1 over 3, 1 plus 1 square plus c times 1 plus 1 to the power of negative 1, okay? So here we can find the value of c. C is negative 2 over 3. So the particular okay, so the particular solution is y equals 1 over 3 times x squared plus 1 to the power of 2, and c is negative 2 over 3, okay? I write this one as a fraction, okay? Over 3 times x squared plus 1, okay? So this is the final answer of question B. And then let's try to do question 14, okay? 14, find the general solution of the differential equation. So you see that we cannot use separating variables method to do, and also we cannot use type 2, okay, to do it. So firstly, we have to simplify the differential equation to be standard format in type 3. So it will be question A, it will be dy by dx divide cosine x, okay, and then plus divide 1 over cosine is secant x times y equals secant x, okay, equals secant x, okay, and then px is secant x, okay, px is secant x, all right. So so now we are going to find the integrating factor. So e to the power of the integral of secant x dx. Okay. So now how to find the indefinite integral of secant x? Okay. So integrate secant x is not easy. Okay. So you should know how to do. Here, there's a tricky way. Okay. A tricky way. So we should multiply secant x plus tangent x to it. But if you multiply secant x plus tangent x, you should divide it also. And then do expansion on the numerator. So it becomes secant x squared plus tangent x secant x over secant x plus tangent x dx, okay, dx. And after that, we know how, okay, we know for the numerator, you know that, okay, for the numerator, you know that the derivative of tangent is secant squared. The derivative of secant is tangent x secant x. So it means that we can remove these two terms into d. So it becomes 1 over, okay, secant x plus tangent x. It is just, okay, the primitive function, with d tangent x, it is secant x squared. With d secant x, it is tangent x secant x, okay? So we can write in this way. And now you see, this is u, so it will be ln absolute value of secant x plus tangent x plus constant c, okay? So if you can remember the result, okay, please remember that the indefinite integral of secant x is ln absolute value of secant x plus tangent x plus constant c, okay? So here we get a new result, okay? We have learned sine, cosine, tangent, cotangent, we have sine, cosine, okay? And also integrate the other kind of integrate tangent, we also learn it, okay? Cotangent, we also learn it. But here, this is the first time to integrate secant x, okay, secant x. So we have no 5 kinds of the indefinite integral of 5 kinds of trigonometry functions, okay. So here the this one, okay, so the integrating factor will be, okay, e to the power of ln absolute value of secant x plus tangent x, okay. So I don't choose constant c, okay, choose constant c, okay. And then it will be, okay, the absolute value of secant x plus tangent x, okay. So the integrating, okay, the integrating factor can be, okay, we choose the positive one without absolute value sign. It will be secant x plus tangent x, okay. So now we multiply the integrating factor on both sides to the standard equation, okay. So it will be secant x plus tangent x times dy by dx plus here we merge secant, okay, so we simplify the result here. So it will be secant x squared plus tangent x secant x times y equals, okay, equals secant x squared plus tangent x secant x, okay? And now the left hand side can be written as the derivative of a product, okay? So it will be y times secant x plus tangent x by dx, okay? So dy by dx, and keep secant x tangent x correct, okay? Correct. And d secant x tangent x, it should be secant square. It should be secant square, and then tangent x secant x, okay? It is correct also, okay? So we get the correct left hand side, okay? The correct left hand side, and the right hand side is secant x squared plus tangent x secant x, okay? And now we multiply dx on both sides. And then integrate on both sides. And then it will be y secant x plus tangent x equals, okay, so whose derivative is secant x squared, okay? We want to find the primitive function, okay? So it should be tangent x, and d secant, it will be the primitive function, d secant, it will be tangent x secant x, okay? So it means that the primitive function of tangent x secant x is secant x, okay, and then plus constant c, okay? So finally, y will be tangent x plus secant x plus c over tangent x plus secant x, and which can be written as 1 plus c over tangent x plus secant x, okay? So this is question A. And question B, find a particular solution which satisfies the condition y equals 2 and x equals 0. So B, when x equals 0, y equals 2. So we can have 2 equals 1 plus c over, okay, so tangent 0 is 0, secant 0 is 1, okay, because secant x equals 1 over cosine x. So secant 0 equals 1 over cosine 0. Cosine 0 is 1, okay? So here we can find the value of c. So c is 1, okay? Find the value of c. So finally, the particular solution, okay? So the particular is y equals 1 plus 1 over tangent x plus secant x. Okay, that's all. So this is the answer of question 14. Okay.